Hi, and welcome to this video on systems of linear inequalities. Okay, well, we've talked about linear inequalities, so now we're going to talk about a system of linear inequalities. We also talked about a system of linear equations, and so just like a system of linear equations, similar to that is a system of linear inequalities. That means that you have two or more. So a set of two or more inequalities, just like in a system of equations is a set of two or more equations. Okay, so when we're talking about a system of linear inequalities, they share the same variables, usually x and y, and so they're graphed on the same coordinate plane. Okay, so basically, let's talk about the boundary. Okay, so last time we talked about the boundary of inequalities. We talked about solid lines, dashed lines, right? We talked about when your solutions are included, it's shown by a solid or dashed line or curve, right? And so we said that it's usually less than or equal to or greater than or equal to for those symbols. And when your solutions are not included, they're shown on the graph by a dashed line or curve, and so that's less than or greater than, okay, which means that the solutions on the boundary are not included. So let's quickly go through this. Let's kind of recap. All right, so I have some examples below. And so what I have is the inequality y is greater than x. Well, that's very similar to the line y equals x. And so I'm going to graph this boundary as a line. So it starts at the origin, the y-intercept, and it's a one-to-one slope. Okay, so we have our line here. And because of this greater than symbol, that tells me that my line will be dashed. And it tells me that my line is also greater than, so I'm going to shade above. My solutions are above my line. Okay, so when I graph this one, it's going to look something like this. So I have a dashed line, and I'm going to shade. Let's try yellow. So I'm going to shade above that line. Okay, and so any of my solutions that I would have would be solutions in this region up here. So I could pick negative 5, 5. That would be a solution. I could pick maybe 3, 6. That would be a solution. Or I could even pick a point down here in this region. Let's say negative 7, negative 2. Okay, so any of those would be solutions, except for the points on the boundary. If I picked a point on the boundary, any of these points would not be included in my solution. So I couldn't use the point 0, 0. I couldn't use any of the other points that are on this line. None of those would work. I could not use 10, 10 or negative 10, negative 10. I couldn't use any of those. Okay, but I could use negative 10, 10. Okay, so let's look at the other one. And I'm going to shade this one. So I have y is less than negative 2x. So again, my y-intercept is 0. My slope is negative 2 over 1. So I'm going to use that to graph my boundary. And so the boundary is up to right 1. Actually, that's incorrect. Let's try that again. So I'm going to go down to left 1. So up to left 1. So down to right 1. Excuse me. Down to right 1. Down to right 1. Down to right 1. Up to left 1. And making sure that I'm just staying on the right track so that I get a good line. And in this case, this inequality tells me that that I'm going to shade a solid, or I'm going to make a solid line because it's less than or equal to, it has the bar under it. So I have a solid line with a slope of negative 2 and a y-intercept of 0, 0. And less than tells me that I'm going to shade below. Okay, so my solutions are found below my inequality. So I'm going to use the blue to shade below. Okay, so this is under the line below. All right. So what I have are those two inequalities, and these are two separate inequalities. Okay, so what I'm going to do now after that is I'm going to graph what's called a system. So technically these will be included on the same coordinate plane. So down here we're going to go and graph our system. So I have the same inequalities that I'm working with. I have y is greater than x, so that means, remember the dashed line, and it's greater than, so I shade above. And for the second inequality, I have a solid line, and I'm shading below. Okay, so I'm going to go and graph those the same way that I just did the inequalities above, but now I'm going to put them on the same graph. So let's look at that. 1 to 1, starting at the origin, 0, 0. Okay, so now I'm gonna dash my line. All right, so then I'm gonna go ahead and shade the first inequality. Remember, it was above. We're just gonna go up here to shade above again. Okay, it doesn't have to be very neat, but just so you get the idea, as long as you know where the solutions are. So then now I'm gonna shade the second line, or this, I'm gonna graph the second inequality. So starting here, I'm gonna go have a negative slope. And this line will be solid. And this one is being shaded below. I'm going to try this one in green. Okay, so what's happening is I'm shading below my inequality. Oops, I don't want to use that color. I'm going to try a different color. I'm going to try blue. Blue. Okay, so notice I'm shading under the inequality, still shading below. But what happens once I start crossing over where my region is included for the inequality before it? Well, you notice that there's a green region created from the yellow and blue. Okay, remember yellow and blue make green. So what this is called is our overlapping region. Okay, so for this particular inequality, all of my solutions are found anywhere where the two inequalities overlap. Okay, so if I were to continue, oh, I lost it again. It's acting a little weird. Let me reshade that. So if I were to continue shading to infinity, basically any solutions that are under the blue line and above the dotted black line would actually satisfy my inequality. Okay, so I could go here, here, here. Okay, so let's pick some points to test. I'm going to test the point negative 10, 1. Okay, negative 10, 1. So let's test negative 10, 1. So basically that means that it has to work for both inequalities. It has to satisfy both inequalities for it to be a valid solution. So if I put in 1 is greater than negative 10, well, that's actually true. And then for the second inequality, I'm going to use the same point to test. So 1 is less than or equal to negative 2 times negative 10. And in this case, negative 2 times negative 10 is positive 20, and so 1 is less than 20, so that's true. So 10, 1 is a solution. Now let's also look at the boundary. So notice that in this region, we talked about the boundaries being included and not included in our solutions. So for the second inequality, the boundary actually is included. So I could pick any point on this boundary, on this line, y equals negative 2x. So let's try negative 2. This will be negative 2, positive 4. So I'm going to test that point. Okay, so negative 2, positive 4. So 4 is greater than negative 2. That's true. And y is, and I'm going to replace y this time in the second inequality. So that's going to be 4 is less than or equal to negative 2 times, what did I put in, negative 2? So 4 is less than or equal to 4. And that is actually true. Okay, so both of these points satisfy the point on the boundary and the point that's in the region. Now, if I picked a point down here, this point would not satisfy my inequality. So let's pick a point down here and just test it anyway. Let's try negative 1, negative 1. Okay, if I were to try negative 1, negative 1, negative 1 is greater than negative 1. Well, that's not true. That doesn't work. And if it doesn't work in the first one, we know that it's not going to work in the second one. But we can just test it just to be sure. So negative 1 is less than or equal to negative 2 times, and that's going to be negative 1. So negative 1 is less than or equal to 2. That's true. So why does that happen? Well, it happens because it does satisfy the second inequality. Negative 1 is in the blue region. Okay, so it does satisfy. However, it does not satisfy both inequalities, so it cannot be a solution. Okay, so negative 1, no, it's not a solution. Okay, now we know that any point in the yellow would also not be a solution. And then any point in the blue region would not be a solution, and especially in the white, because that wouldn't satisfy either inequality. Okay, so the only points that satisfy our inequalities are the points that are in this green region here, and the points that are on the upper boundary but not the lower boundary. Okay, so I hope this has helped your understanding of graphing or solving inequalities by graphing. And check out the next video as we go more into detail.